The following video is an overview of the information you will read in this week's text. Remember, the text includes more details, more examples, and more information, so please still refer to your text for the information you need for this week's content. The theme of this chapter is rational expressions. So the first thing you need to understand is what is a rational expression. A rational number is the ratio of two integers with the denominator not equal to 0. Basically, that means a fraction. Some examples are listed here. Other examples can be expressions with x's or y's or other variables in them, but basically a rational expression is in the form of a fraction. The first thing we're going to talk about this week is domain. The domain of any algebraic expression is the set of all numbers that can be used to replace the variable. So if you look at that example down below, I'm looking for all of the numbers that I could plug in for x and get a real value as an answer. In rational numbers, such as this one, you need to be careful that the denominator never equals 0. If the denominator equals 0, we get an undefined answer. So that is not part of the domain. When solving for the domain, you're going to look for the place where the denominator is equal to 0. So for this problem, we're going to do x squared minus x minus 6 equals 0. If we can solve for that problem, we're going to discover what values x can't be. The way we solve a quadratic equation is by factoring. I'm not going to take too long to review factoring here because you learned that in the last class. If you need a review on factoring, I would encourage you to go to YouTube or Google, type in factoring, and see if you can find a tutorial to help you with that. In this problem, I'm going to factor x squared minus x minus 6. That factors to x minus 3, x plus 2. So now we're looking for the places where x equals 0. So we have two problems. We have the problem where x minus 3 equals 0, because if this equals 0, 0 times anything is equal to 0. So by adding 3 to both sides here, you get x equals 3. So that's one location that x cannot be 3. You also have to check the x plus 2. If x plus 2 equals 0, anything times 0 is 0. So that's going to cause a domain issue as well. So here we have x plus 2 equal to 0. Subtract the 2 from both sides, and we get x equals negative 2. So x can also not equal negative 2. The domain of this problem, therefore, is all real numbers except x cannot equal negative 2 or 3. Next, we're going to talk about how to reduce to the lowest terms. And the first thing you want to do is factor the numerator and denominator completely. Divide the numerator and denominator by the greatest common factor. Starting out easy, you have the first one, which is 10 divided by 35. Look for the greatest common factor. The biggest number that goes into both 10 and 35 is 5. So if you divide the top by 5, you get 2. And the bottom by 5, you get 7. That's reducing it to the lowest term. In the next one, the greatest common factor that goes into 5 and 20 is also 5. So reduce 5 divided by 5 is 1. 20 divided by 5 is 4. With your x's, you're looking for the greatest common factor again. There's an x squared in the top and x cubed in the bottom. Basically what that means here is there's one extra x on the bottom than there is on the top. So you're going to have one x left over on the bottom. And with the y's, there's one extra y on the top than there is on the bottom. So you're going to have one y left on the top. In the last example, it's a little bit harder. The first thing you need to do is factor completely. Notice the top here is a difference of two squares. So I can factor that to x minus 3, x plus 3. If you need to review that, Google difference of two squares and get some information on that. On the bottom, we have a greatest common factor of 6. So I'm going to pull the 6 out front, and what's left inside is x plus 3. Now, the best thing about this situation is that you notice there's an x plus 3 on the top and an x plus 3 on the bottom. Those cancel each other out. And then your final answer, since nothing else cancels, is x minus 3 over 6. When multiplying rational expressions, the first thing you want to do is see if you can reduce anything. In my first problem here, I have a y on the top and a y on the bottom that cancel each other out. The 3 also reduces the 9. So that can be reduced as well. And that's going to save you a little bit of work in the end. So if you reduce first, you save yourself some work. So now let's multiply across. Left on the top, we have 3, and then x squared. And on the bottom, y squared. The second problem is a little bit more challenging because it's not as obvious if anything cancels. Just like we did in the last slide, you're going to try to factor to see if anything reduces. Factoring that first fraction on the top, I get x plus 3 times x plus 4. On the bottom, factoring out the greatest common factor of 2, I get 2 times x plus 3. Second fraction, the top's pretty simple. On the bottom, we have a difference of two squares. So x minus 4, x plus 4. So now you want to check and see if there's anything that's going to cancel. Notice you do have an x plus 3 on the bottom and the top. Those are going to cancel each other right out. You also have an x plus 4 on the top and an x plus 4 on the bottom. So that cancels each other out as well. Once we cancel all these things out, we're left with a much simpler problem. All that's left on the top is x. On the bottom it's 2 and x minus 4. You are going to want to go ahead and distribute that 2, and you get x over 2x minus 8. A very common mistake is to try to cancel out those x's. They don't cancel because remember they aren't factors. Unless you've completely factored and they're exactly the same, nothing cancels. So this is your final answer. So now we're going to talk about dividing rational expressions. Dividing rational expressions is very similar to multiplication. What you want to do is start by factoring all of the pieces if possible. So looking at this example here, the top is a difference of two squares, so we get 2 minus x and 2 plus x. The bottom has a greatest common factor of x. The second fraction here, that top cannot be factored, but the bottom is a difference of two squares. Now, division of fractions is the same as multiplying by the reciprocal. So the next thing I'm going to do is I'm just going to flip the second fraction. The first fraction stays exactly the way it is, but the second one is going to be flipped because we're multiplying by the reciprocal. And now we want to see if we can cross cancel anything. So notice here we have an x plus 1 on the bottom and an x plus 1 on the top. Those can cancel each other out. Now we don't have anything else that's directly related, or at least can directly cancel. But do pay attention to the fact that here you have an x minus 2 and here you have a 2 minus x. Those are pretty similar, and we might be able to make them the same. In fact, if we take this first one and over to the side here, we think about that 2 minus x is the same as negative x plus 2, right? So if I want to see if I can turn it into the other one, I'm going to factor out a negative and get negative x minus 2. So now this part here can become negative x minus 2, which means it can cancel with that one on the bottom. So let's see what we have left. We're going to have that negative sign left. We're going to have a 2 plus x and an x minus 1 on the top. And we only have an x on the bottom. Great. Now, just to finalize it, you are going to want to multiply out the top. So start by foiling. We'll leave that negative out front for a second. We get 2x for first. Outside is negative 2. Inside is x squared. Last is negative x. We're going to simplify that a little more. I'm going to reorder things here. So I get x squared. We have a 2x and a negative x, so that just leaves plus 1x minus 2. And that's all over x. And then distributing that minus sign gets me a negative x squared minus x plus 2 all over x. And that is our solution. We went through that a little quick, so feel free to pause this and go back and kind of look through it again. Make sure that you can follow through everything that we did. When you add or subtract rational expressions, you first need to find a common denominator. You're going to look for something that both denominators can go into so you can make them the same. Looking at 20 and 12, you're trying to find a denominator that both 20 and 12 go into. You play with it a little bit and you figure out that the lowest common denominator is 60. So I'm going to change both of my fractions to have a denominator of 60. To get the 20 to turn into a 60, I got to multiply by 3. So I have to do the same thing to the top, and I get 9 over 60. To turn the 12 into a 60, I got to multiply by 5. So I do the same thing to the top, and I get 35 over 60. Add those together, and I get 44 over 60, which can then be reduced by 4 on the top to make 11 and 4 on the bottom to make 15. We're going to apply the same principle to a harder problem now. Now, when you think about what we're doing here, we need to find a common denominator. So we need a number that both x plus 2 and x minus 1 go into. Since it's not really a number, it's an expression, we have to create an expression that they both get into. The easiest way is to multiply them by each other. So I'm going to create a common denominator of x plus 2 times x minus 1. Now, in order to do that, like I did last time, in this first equation, if I multiply by x minus 1, I have to do the same thing to the top. So on the top, I'm going to get 2x squared minus 2x. Notice I distributed that 2x because I know I'm going to combine things later. In the second fraction, I have to multiply by x plus 2 on the top and the bottom. So I get 4x plus 8. Now that I have a common denominator, I can combine the tops. So let's see, I get a 2x squared, that stays where it is. Negative 2x minus 4x is negative 6x. And then I have minus here, 8. And then your denominator, I'm going to leave for right now as x plus 2, x minus 1. Now the reason I'm doing that is because hopefully later I can factor things and cancel things out. So I might as well leave it in factor form. Now let's see what I can do with the top here. First there's a greatest common factor. So I'm going to factor out the 2. And I get x squared minus 3x minus 4. Again, denominator stays the same. Can factor the top to x minus 4, x plus 1. And since nothing cancels, there's really nothing else I can do to this problem. So we've spent a lot of time working with rational expressions, trying to figure out how to simplify them in various ways. Now we're going to use those concepts that we've learned to talk about how to solve a rational equation. Look for the values of x that make an equation true. In this example, we're going to start out the same way we did our last example, and that we first need to be able to combine that addition together. The only way we can do that is to get a common denominator. The common denominator is going to be x times x plus 5. So, in the first fraction, we multiplied by x plus 5 on the bottom, so we have to do the same thing to the top. In the second fraction, we multiplied by x, so we have to do the same thing to the top. Now, what's different about this problem is that So to make our lives a little bit simpler now, we're going to add these together, but we can also get rid of the denominator by moving it to the other side. I'm going to multiply both sides by that denominator, so the denominator goes away on the left side, but joins on the right side. And then we're just left with the numerator on this side. So let's simplify here. We get 100x plus 500 through distribution plus 100x equals 9x squared plus 45x. I'm going to move the right side over by subtracting 9x squared and subtracting 45x. I'm also going to combine some like terms here. So I'm going to have a negative 9x squared. And we have 200x on this side minus 45 is plus 155x plus 500. And that equals 0. Alright, so here's what we're left with. We have a quadratic equation set equal to 0. When we solve quadratic equations, we want them always set equal to 0. And then the first thing you want to try is to see if you can factor it. In this case, we can. It factors to negative 9x minus 25 times x minus 20. So now remember, when we have an expression like this with two numbers multiplied by each other that equals 0. If either of the factors equals 0, then the whole thing equals 0. So we have two problems. Negative 9x minus 25 equals 0, and x minus 20 equals 0. Solving for x in the first one gives you 25 over negative 9. And solving for x in the second one gives you x equals 20. Those are your two solutions to this equation. Remember, you should go back and plug in your x's just to double check and make sure they work. That's an easy way to verify that you got the right answer. So in this example, I'm going to, once again, solve an equation. We have addition here, so we need a common denominator. The first thing I'm just going to think about right here is that is the same as 2 times x minus 2, so I factor that out. My common denominator in this case is going to be 2 times x minus 2. So in the first one, I had to multiply everything by 2. The second fraction is fine just the way it is. The third fraction I had to multiply by 2 and x minus 2 on the bottom, so I got to do the same thing to the top. So now I'm going to leave the bottom alone because the bottom is already consistent, so we don't really need to worry about the denominator. Let's find out when the numerators are equal. So here we have 2 equals x plus 2 times x minus 2. I'm going to expand that out a little bit using the distributive property. Combine like terms. Now I'm going to solve, so I add 4 to both sides. I get 3x is equal to 6. Divide by 3, and I get x equals 2. Now, remember, I only worried about the numerator because the denominator was already equal on both sides. So no matter what number I plug in to that bottom, it's always going to be equal. So I only really need to worry about the numerator. The only downside to that, though, is the denominator does exist. And the denominator sometimes creates domain issues. Remember, we can't divide by 0. So if the denominator is ever equal to 0, we have something that doesn't work. Well, look what happens when I plug in my solution into my denominator. I get 2 times x minus 2, which is 2 minus 2, which gets me 2 times 0. Oh no, that doesn't work. I can't have a 0 in the denominator. So x equals 2 is actually not in the domain of my function. This is called an extraneous solution. That means that it's a solution technically, but it doesn't actually work because it defies the domain laws. It creates something that doesn't exist. So whenever you get an answer for one of these equations, always check and make sure it's in the domain. If you plug it into that denominator and it doesn't work, or if you plug it in anywhere and it doesn't work, it's called an extraneous solution, and you need to throw it out. So this problem actually has no solution. So those are your highlights from week 1. Make sure you go back, review the text and these supplemental materials to get all of the information, and then get to work on your assignments. Thanks.